Hi, I'm Tom Bridge, and for 20 years I've worked in IT. I first for an education nonprofit, and then for a consulting company that I founded and ran, where I handled Apple-facing IT for small to medium-sized enterprises all over the United States, mostly on the Eastern Seaboard, mostly in the Washington, D.C. area. Our biggest customer had thousands of people and dozens of interrelated systems put together by work that we did in IT. During that time, we developed a lot of software to support their businesses, as well as integrated with half a dozen different MDMs and IDPs of different varieties. So now I'm the director of product for device management at a company called JumpCloud. We're an IDP and a device manager put together. And we make remote work happen at JumpCloud. And we do it through identity management and device management. I work every day with our engineering teams. I was just on a call this morning with our folks in Denver, and I will be on a call later tonight with our folks in Singapore. We are all over the world. We are a global company, and we're growing like crazy. But I'm here to talk a little bit today about a subject I know something about, and that's running after the ice cream truck. And so there's this thing in the States, and I hope it's a thing here too, and you're sitting in the backyard on a hot summer day, it's about 40 C out, you're sweating like crazy, you're hungry, and you hear the sound. And in the States, it's a cheap MIDI recording of Turkey in the Straw. And it's loud, and you hear it from a block away, and it's the moment that makes your summer afternoon better. It's, the fact that you still have a couple of bucks left from grandma from your last trip to see her. And it's in that moment that you have a great deal of hope and joy. And it's a moment of relief in an otherwise difficult situation where you're just dying out there of heat exhaustion. And so you tear into the house and you run upstairs to your piggy bank and you grab that money and you sprint back downstairs looking for that ice cream truck. That sound is innate. It is inside of you. You've heard it before. You will hear it again. It is a sound of joy, and it is something that you have to hustle for. This talk is part history, part self-help course, part commiseration, and absolutely, positively part whiteboard session. If you think about the pace of change, as I do now a lot with a 9-year-old at home who was 6 when we started the pandemic, and that 10 years in between those 3 moments certainly has felt like a lot. Everything is changing all of the time. Who here saw Everything Everywhere All at Once? Who here felt that in their soul? Very definitely. The amount of change that we have to deal with in just a year or two feels larger than it's ever felt before. This talk isn't here to argue that a faster cycle is better or worse, because they're indifferent. The cycle of change that we find ourselves in is a reality of our world over which we have little to no control. The last time I was here in Melbourne, my wife and I spent a day at the Melbourne Museum, and we took in a history of the city there and really enjoyed learning about the place that we'd come to visit. Melbourne's a lot like my home city of Sacramento in a number of ways. It has a vibrant pre-colonial history, and the Wurundjeri people whose land we are on today are very much like the Nisenan people of the Central Valley, where I grew up. In addition, the city was built by colonizers as a part of the gold rush of 1851, mirrors the discovery of gold in the Sierra Nevadas in 1849, that led to a rush on the fertile farmland at the foot of those mountains as the navigable rivers that were there that allowed us to get to Sacramento. And so that moment, that place, feels like home to me. And in many ways, Melbourne feels a lot like the place I grew up. Gold rush towns are special places. They know the cycles of boom and bust, and they have some of the most resilient people alive. Cycles like that of economic expansion and contraction can come with a great deal of change for areas, and it's not always pleasant change for those people who experience them. Sound a little familiar, I hope? Gold rushes are useful reminders that sometimes you have to act fast to get results, and sometimes you must be patient for the next cycle. With all good things, with indeed all hard things, there are some criteria for success that must be planned for and met in order to win out. One of these is planning, and one of these is spontaneity. This talk is all about the cycle of development that Apple has built across its lifespan and how to deal with the constant tick-tock. In the beginning, there was the system. Early Macs ran on the system software. It didn't have a name other than being the system. It said system on the diskette that you put inside the Mac. System 1 was released as part of the original Macintosh in January of 1984. It lasted all of 11 months before it was supplanted in December of that year with System 2. The Finder and the menu bar were the two killer apps, hallmarks of a graphical desktop. The trash got emptied when the Finder got quit, and the whole thing filled 216 kilobytes of storage. Launching apps meant ejecting the system disk and inserting the application disk and going to town from there. It was a magnificent time when you think about it. System 2 was released in March of 1985, bringing with it the ability to create folders in the file system, welcoming HFS Plus for the very first time, as well as screenshots, one of the oldest, most useful technologies, and the keyboard shortcut remains unchanged today, Command-Shift-3. And the ability to select a new printer was also a brand new networking technology called AppleTalk, was all there as part of System 2. System 3 was released in January of 1986. Again, 2 years, 2 major operating systems, with ground-up support for HFS, SCSI, and AppleShare. This was starting to look like a real operating system at this point, and indeed was probably the operating system they intended to release in 1984. External hard disks were now possible with the Mac Plus and could be attached to the original 512K Mac with an additional port attached to the motherboard. System 4 was released in 1987, and with the release of the Mac SE, a year after the System 3, System 4.1 in March of that year with the Macintosh 2, a full-size desktop with an external display, including a 13-inch color monitor from a partnership with Sony Trinitron. The Mac was now in color. Well, sort of. 16 colors at 640 by 480, or 256 magnificent colors at 512 by 384. With support for the 68020 processor series, it was Apple's first foray towards faster chip performance. All of these updates meant getting physical disks from place to place to place. Labels printed, shipped correctly and safely, as magnetic media, as we all know, is a little bit sensitive, especially those tiny flimsy diskettes, which would frequently fail after a short period of time. The first 4 systems feel very much of a piece to me, and delivering in each release a major chunk of functionality that was likely carved away from a complete product vision for the Macintosh, down to the minimum viable product for the original Mac 128K. And it took them 4 years to get to where they wanted to be in the initial part. System 5 marked Apple's 4th major upgrade cycle in 4 years, and was the first of these upgrades to be paid for. It was $49 for 4 floppies and 3 manuals. Of course, if you were part of a user group, you could get it for just the cost of the diskettes, and your local distributor would handle that with a social event for their customers in a lot of these cases. System 5, well, in reality, it was Finder 4.2, right? Is released with cooperative multitasking, which is a little bit of a misnomer, but it works well and it's very workable for the day. System 6 changed everything for Mac owners again and ushered in a stability period for the Apple environment, arriving in April of 1988 and supporting the SuperDrive, a 1.44 megabyte floppy disk, and supporting the original 68030 Macs, the 2X and the SE30. System 6 would be the first Apple release to go for a longer period of time, with maintenance releases lasting through March of 1992 and functional releases lasting through May of 1991. It's Apple's longest period without what could be classified as a major update. System 6 introduces PostScript for printing as well as HFS support for volumes up to 2 gigabytes in size. Most importantly, the Achilles heel of the Mac has been identified: 24-bit memory support. Even though the Motorola processors they are using are 32-bit capable, an early design choice has limited the address space to just 3 bytes. RAM limits become a major frustration for developers and users alike. And so we find ourselves in 1991, 3 years after the system release of System 6. And Mac users have been wondering, after such a rapid pace of development, what could Apple possibly be thinking is up next? What have they been doing down there at Infinite Loop? After the release of System 6, Apple knew that they had some choices to make. In a summit meeting in Pescadero, California, just south of San Francisco on Highway 1, Apple engineers gathered to debate what happens next and how quickly it could happen. They started with pink and blue index cards. And so they started to figure out, and there were some other colors as well. There were some red and green cards. We'll talk about those a little bit more as we go into the future. But the big concepts were fix it in System 7 or fix it in System 8. Blue cards were meant to be quick wins, while pink cards were meant to be longer solutions to thornier and more theoretical problems, which required more plumbing inside the operating system. The blue team became known as the Blue Meanies, and Charles Edge found me this lovely frame from Yellow Submarine to go along with this slide, and I thank him for it. It's a tribute to the antagonist from Yellow Submarine, the Beatles movie from 1968, about a psychedelic vision, because the team was fairly fanatical about what represented a quick win versus what was going to be included in System 8 and beyond. Architects are supposed to do that. Software architects are supposed to make the hard decisions of, is this right now or is this not right now? That's not supposed to be just the realm of the product manager to do. So what was one of the first things they put on one of those blue cards? 32-bit memory management. Other cards were added for 32-bit quick draw, mandatory cooperative multitasking, because the previous version was opt-in. And guess what? If you didn't like the fact that you might have to share your resources, you just didn't opt in. And so it wasn't a part of your reality. Formalization, of course, of system extensions from dirty hack to feature, file system niceties, drag and drop, AppleScript, pub sub models, TrueType, and colorized UI throughout the system were added to blue cards, which became part of the reality. And so this leads us to a very interesting spot, which is to say System 7. Now, System 7 came with it a real challenge. The original Mac Plus was the first Mac that could achieve the 4 megabytes of RAM limit that 24-bit addressing could handle. However, that was released in 1985. We are now in 1991. The original 128K, after 4 megs, could feel expansive. 4 megs could feel like a reality of wealth in that time. However, by 1988, most Macs are shipping with 8 megs of RAM, but the operating system can't really do much more than that at this point. To learn more about this era, I went and talked to a couple of devs from that era, including some who are still active today. Some have agreed to go on record with their experiences, and others have wished to remain anonymous to prevent the sins of their past from spreading. When I wanted to get a better handle about this, I asked Rich Siegel of Bare Bones about the memory management systems on the early Mac. And what he had to say was, so the original 68000 had a 24-bit address space, which meant that the high order 8 bits of any given pointer were unused. Since resources were limited, the original Macs had only 128K of RAM and an 8 megahertz clock. It was typical to use that valuable 8 bits for other things. A common application for that storage was metadata about the pointer itself. For example, the Mac Memory Manager had the concept of relocatable memory storage. You could ask the API to allocate memory, and it would give you back a pointer to a pointer called a handle. This first order pointer was the address of a pointer in a table which pointed to the actual storage itself, a master pointer. If the OS needed to, it could relocate the memory that had been allocated, and after doing so, it would update the master pointer to the new value. Thus, the original handle returned to the client code that never changed, even if the physical location of the allocated memory did. In a 24-bit address space, the memory manager would use the high byte of the master pointer to store metadata about the allocated block. whether it was locked, which prevented relocation, a resource, a specific type of data read from disk, or it was purgeable, could be released to relieve memory pressure, and such like. In a 32-bit world, that metadata had to go somewhere else because it now corresponded to things outside of your space. The problem was that a lot of client code would examine and or manipulate the master pointer flags directly, which broke or would mask off the pointer values and the resulting 24-bit address space directly for calculations. And that's just the intersection with the Mac memory manager. It was quite common for a highly optimized 68K assembly code that didn't use the Mac memory manager to use the high byte of pointers to store metadata about whatever data structure the pointer represented, because it was a single mask operation. And so with System 7, Apple has declared that 32-bit clean is the way to be. Who remembers this transition? I do vaguely, and I was going to say, I see a couple of other hands go up here. The devs who lived in that time had very different constraints than the ones we do now. And the fact that any of this works at all is a miracle, which is delightful. So Apple declares that 32-bit clean is the way to be. And so, if we think about, the past that we lived in and where we are going, we get to this spot. The metadata had to go somewhere else. A lot of client code could re-examine those master pointer flags directly, and so your mask operations would fail, and your app would crash. And so we get probably one of my most favorite spots of this, which is TechNote 212 from Apple in late 1988. It has one of the very best software engineering maxims I have ever heard. Don't make any assumptions, even if those assumptions are currently true. The future will change. And so this note, which is still available thanks to the glory of the Internet Archive, is probably one of the single best tech documents that I've read from Apple in its entire history. It is opinionated, it is clear, and it is prescriptive on what you may do and what you may not. That is something where Apple is maybe not as aggressive now as perhaps they were in their infancy. Getting 32-bit clean was all about supporting your existing customers through the change. It was some time before the older players did it, as a matter of fact, and many would call the challenge of their careers to architect their code to match a 32-bit memory space. However, that was not the only challenge that Apple developers and admins faced. By the release of the 68040 processors, or the 040 processors, the Motorola and Apple were struggling to keep up with the Intel world. Clock speed was king, and 40 megahertz in the 040 was enough to keep the Mac humming, but it wasn't clear if there was going to be a next generation of faster, stronger, better than these 32-bit chips. The 88,000 series at Motorola were not as bulletproof in their testing environment and were a bit of a disaster-prone chip family. In a lot of ways, Motorola's failure here drove Apple's choices. The Motorola and Intel chips were all based on CISC architecture, complex instruction set computing, designed to limit how much assembly you needed to do as part of these processes. In the 1970s, IBM began to experiment with processors that had fewer instruction sets, but could run them substantially faster. You'll notice we're sheerly focused on the Blue Minis at this point in the time on the operating system world, but that doesn't mean the Pink team at Apple were anything but busy. Pink was focused on building a very different kind of OS for the Apple products. With a partnership with Motorola and IBM, the AIM Alliance, they were hard at work at looking at different futures for the Pink project. One of the results here was the focus on the IBM performance optimized with enhanced RISC program inside of IBM. The PowerPC chipset was Apple's future, beginning with macOS 7.1.2 and the PowerMac 6160. Those are great boxes. They were totally different from a design perspective than the previous Macs that followed them. There was an elegance to their physical design as well as to the software and hardware design that had gone with them. The challenge here was a wholesale change to the kind of instruction sets that ran in RISC as opposed to CISC conditions. Apple had a challenge here. How do you get people to rewrite everything? They evaluated options that would put both a PowerPC and a 68,000 series in the same box. finance said, no, that's a terrible idea. We can't afford to make those computers. And so an emulation layer was settled upon, and it became possible, despite the performance hit, to emulate the 68,000 series code on PowerPC processors. Called Project Star Trek first and later Project Cognac, they both provided major work for porting the Apple operating systems to PowerPC chips. That led to solid emulation layers for native code. And so developers could ship fat binaries, the very first of the fat binaries that we've seen, that contained executables for both processor families. In the event that you only shipped old Motorola code, it would run in emulation mode on the PowerPC chips. The transition was widely regarded as a huge success. And so we start to see here, as we hit 1994 and so the release of System 7.1.2, a future here that we are still hanging out in the world of System 7. And so we see a little bit more here as we go through this process, as we sketch out the future. We get to 1994 and System 7.5 releases with OpenDoc and Mac TCP included by default, instead of you having to get it on floppy disk from your best friend who would make you a copy in spare time in exchange for, you know, a couple of floppy disks of his own. But where does that leave System 7's stability? And the answer is System 7's stability, its long tenure as part of the operating system, was actually a foil for the cost of the company's long-term future largely. So we talked a little bit about Pink and the System 8 in that 1994 to 1997 period. The Pink team around System 8 is called Copeland internally. You may have read about it as a part of its history. It began to suffer from second system syndrome, and the delays began to pile up as Apple struggled to express its new operating system vision into software that people could use on a day-to-day basis. In fact, the bloat around the project itself ended up collapsing the entire operation. The Taligent company was a joint project between IBM and Apple to get their operating system running on Intel chips at the time. Again, you'll notice I didn't say PowerPC. This is still the mid-90s. There was an attempt by Taligent and IBM to get the Apple operating system running on Intel chips so that IBM could sell the Mac OS, generally speaking. Part of the process that we saw in all of this, that 5-year reign of System 7 is Apple's most stable period as an operating system and its biggest failure as a company. The Mac isn't selling well, due in part to uninspired hardware design and software challenges. All of the Pink features that were promised in the future of the Mac, real multitasking, protected memory management, and the future of the Mac were undelivered upon in working operating systems. And what could be salvaged out of the Pink project was turned into System 8 and by Ellen Hancock, who was at the time the head of that project. She was able to actually salvage out of that 4 releases, which represent the next 4 years of the Apple environment. And so we hit the end of the period at the end of 1996, where Apple spent $400 million in cash and stock that they largely did not have to buy a company called Next, founded by Steve Jobs after his 1985 ouster from Apple. They beat out another former Apple pair, Steve Sackerman and Jean-Louis Gasset of B. The OpenStep programming environment that Sun and Next co-developed was the future of Apple's development and the, well, forgive the pun, next generation operating system from the Next group. It gave Apple a modern future to build from. macOS is still being developed, of course, and macOS 8 and 9 are released in 1997 and 1999. It's clearly a dead operating system walking at this point. And the presence of Next folks across all of Apple's hardware, or all of Apple's campus at Infinite Loop, was a harbinger of the things to come for those teams working on old features that were tied to a dead and dying operating system. In the spring of 1997, Apple releases Rhapsody to developers. The name is a bit of a play on words. macOS was supposed to be Copeland, and the next version was supposed to be Gershwin. Gershwin is, of course, the composer of Rhapsody in Blue, and the whole thing was supposed to be quite clever. Instead, it ended up quite annoying. Developers see that on top of the new Mach 2.5 kernel in Unix 4.4 are two options: Yellowbox APIs that you can code for in OpenStep, and a macOS Blue Box compatibility layer. If you want to develop for all of the great new features of the Rhapsody environment, you can't. You have to do it in all new code at this point. Sure, your old code would run in Blue Box, but you were paying a pretty hefty price on the processor for doing so, in that you couldn't talk directly with the hardware that you were working with. This didn't fly at all with developers. Adobe and Microsoft famously pigeonholed Apple to tell them that they wouldn't port their entire apps to OpenStep. There had to be another way. I can only imagine how much fun it was to be in developer relations at that time. Those were probably some very tense phone calls. With key players like Adobe and Microsoft unable to support Rhapsody entirely, Apple is faced with a predicament. Push forward without the core applications necessary to serve your customer base in order to have your best operating posture, or concentrate on a better path for your developers and slow down. It's a choice that Apple can't say no to. In the summer of 1998, Apple introduces the iMac, a new all-in-one internet-forward Mac that abandons old standards in favor of new designs. This is the new Apple, led by Steve Jobs again. And Jobs announces macOS 10 at WWDC that year, and a full transition strategy to replace one of the only two high-volume OSs in the world. It's a fun thing to say when you're number 2 and you're approximately 8% of the market, to say that you're just one of 2 of the high-volume operating systems that are out there. And so we see ourselves here in this chart. Apple begins to release Rhapsody out to folks as part of their release strategy. Hey, take a look at this. It's free to the developers program. Go take a look and see what you can do with this. And in 1997 and 1998, Apple is politely informed that what they have done is not nearly enough on behalf of their people. And so this was a direct slide from Worldwide Developers Conference that year. It says, Rhapsody, nice technology, but doesn't give us what we want. Apple was listening to developers because they had to. And so Apple introduces Carbon, a shared library for macOS 8 and macOS 10. They said that most developers could make their apps ready for Carbon in 1 to 2 months with initial bring up in 5 days or less, for the most part. Apple said that 90% of existing macOS apps code would work with Carbon, and thus could be cross-platform between macOS 9 and macOS 10. When I talked to one developer about the divide between Carbon and Cocoa, though, the path was a lot less clear. It was a very grudging concession because from the outset, the macOS implementation of the Carbon API stack implemented the punish people for not keeping up mentality. Does that sound like any Apple we know today? And in a lot of ways, applications built using it were visibly and behaviorally different from AppKit applications. There may have been a valid technical reason why they did that, but I can't imagine what it might have been, because it created a lot of problems with API shaming, generally speaking. Most organizations, though, were satisfied with the minimal rewrite required to support Carbon and launched on macOS 10 in that environment. Carbon code also served as a huge advantage for developers. The Carbon framework worked on macOS 8.1 and later, as well as macOS 10 through the support of a system extension. The early days of macOS 10 are interesting for a lot of reasons. The first among them is the overlap between the operating systems and the functions in operation. There's a fair amount of trepidation with the original release of macOS 10 in March of 2001. About 18 months later than Steve had said in his 1998 introduction of Carbon. It looks vastly different from its predecessor with an Aqua interface. But does it run any better? Thanks to the work that Apple had done with Carbon, the transition from macOS 9 to 10 was mostly pretty clean. You could build a Carbon app and have it work in both places, while you could transition over to Cocoa APIs over the next 5 years. But that didn't work for every app, and Apple knew that they couldn't get everything moved in time. they announced Classic as a way to continue to run even the oldest of macOS apps and the new operating system together. Classic was indeed a whole second operating system inside the first and allowed developers to skate just a little bit longer. Indeed, Classic ran on PowerPC Macs all the way through macOS 10, 10.4.11, and gave developers just a little longer to complete a full transition. In many ways, it could be a shame factor for developers to be in that box, however, because it was physically limited to a graphical window inside your operating system when it was initially released. The hardest part, having been accomplished by Rhapsody and getting developers across the line by convincing them that they needed to port to Carbon or Cocoa, and Carbon was the easier path, and most of the people took that path. When we think about the PowerPC to Intel transition, excuse me, Apple was fully aware of the flaws of the PowerPC development cycle. Famously, the G5 could not be ported to move to portable Macs, and in fact, the PowerBook G5 was the most common vaporware product rumor for the period of about 5 years. The 3 gigahertz barrier was impossible for Apple to breach, and though Steve Jobs got up on stage and promised that within a year they'd be in that spot, they were not. And so the pathway forward was set. If you're by Apple at that point. In 2005, they announced a 2-year transition to the Intel platform. If you were writing Java or scripts or anything like that, you had no work to do, except everything would be just like it was then. For folks writing Carbon or Cocoa or compiling using the new Apple IDE, Xcode, version 2 had shipped earlier that year. It was just a matter of checking a box at compile time, and a universal binary would be created. There was a little work to do if you were using those tools, granted, but the pathway was clear. If you were still compiling with MetroWorks, however, you had a bit of a different path ahead of you to move over code between a massive IDE. Theo Gray from Mathematica famously said, "Those of you who've been through a Carbon port or a macOS kind of port, this was nothing like that." He famously said that they changed less than 20 lines of code in all of Mathematica to get it working ahead of Worldwide Developers Conference that year. But Apple knew that the path for those customers on MetroWorks was going to be longer than they wanted, so they took a page from a previous transition and wrote Rosetta, an on-the-fly dynamic binary translation layer that shipped with the operating system and ran the PowerPC binaries on Intel, albeit a bit slower. It wasn't enough for Apple to offer developers a path to Xcode 2.1 to help here via universal binaries. It was Rosetta that made this transition fully possible. Moving across IDEs remains a non-trivial task for any code base, and Rosetta gave Apple developers what they need in terms of comfort to not rush the transition. Classic apps, which required the presence of macOS 9 embedded systems, would work a while longer, but would soon be abandoned. At Worldwide Developers Conference that year, Apple demonstrated Photoshop, Office, Quicken, and other non-edited apps on Intel running in Rosetta and working just fine. The average user didn't have to know or care what processor was in their system, just that they were using the latest version of macOS. Apple said that in the 2006 and 2007 years would be transition years, where they sold both PowerPC and Intel chips inside their models and got commitments from Roz Ho of the Microsoft MacBoo and Bruce Chizen of Adobe on stage at Worldwide Developers Conference to get things ported to Intel and Xcodes. The commitments were made, and the transition was a huge success for Apple and developers alike. Beginning with macOS 10.2 Jaguar, Apple moved to an annual release cycle for new operating system. Apple releases numerous new features over the next 6 major releases, including HFS Plus with journaling, fast user switching, Active Directory support in 10.3, and in a surprise release in April of 2005 with no forewarning, Apple releases macOS 10.4. And it becomes the longest release in the modern cycle at nearly 30 months. New APIs exist for core image, data and video and audio, key APIs that are still in use today. In all of this, there have been some challenges, though, including a bit of a middle finger from Apple to developers related to the Carbon API. Apple kept promising that Carbon would be a great way to develop apps. It was, until 64-bit apps came along, and Carbon never got the 64-bit APIs that they needed to produce those kind of environments. Apple kept promising to devs over and over and over again that they would eventually come until they pulled the rug out from under developers and said, you gotta move to Objective-C and Cocoa. That message was particularly frustrating to developers when it came. 10.7 brings Lion, and since its arrival, every year since has featured a new operating system. Lion indeed marked the first mostly online delivery system, with download coming from the App Store in the form of a monolithic application installer that handled the changeover. No longer did you have to boot from a CD or DVD or a USB key that they would sell you to handle an offline update at that point. 10.8 releases the mobile device management specification for the Mac space. 10.9 is the first of the fall releases, a departure from the summer release cycle. And onward and onward and onward we go to another transition. Every year in between, we'd gone from faster chips to faster chips, and slowly over time, the gains had dropped off in the Intel environment. In the summer of 2020, Apple announced a transition from Intel chips to their own chips at the heart of the Mac. For more than a decade, Apple had been making their own processors from the iOS family of devices. Apple's acquisition of PA Semi in 2008 laid that groundwork. Much like the transition to Intel, Apple announced two major programs as part of the transition. Universal 2 binaries, made by Xcode, contain binaries for both processor sets. And indeed, Rosetta 2 would translate existing Mac apps at the install time, as well as handling just-in-time compilers. Unlike Rosetta, though, it wasn't installed by default, causing itself a little bit of a pain in the butt for systems administrator and everywhere. And so at the end of all of this, we've traveled just about 40 years in time to go from System 1 to macOS Ventura, released last fall. In that time, 4 processor families, 3 major other transitions, including the 24-bit to 32-bit clean environment, 36 revisions of note in 40 years. And so you look at the eras that we have here, and there is a ton here that goes into Apple's cycle. As we look into the cycle that we're in now, there's a pattern that's taken shape and held for a long period, and here's how it goes. Worldwide Developers Conference remains in early June each year, and Apple releases a new version of its operating system. To developers and systems admins alike, these betas contain new APIs and technologies, new MDM profiles and enrollment methods, new versions of Swift, new frameworks, and all manner of new and hopefully improved versions of things that represent our livelihoods, the people in this room. There's a few months where we get to kick the tires and experiment with new things, report back on how things are going, and then prepare the wide rollout of new technologies. Early testing favors the prepared, and deep exploration of the state of play is rewarded with knowledge. In many ways, this is the gold rush time that we talked about at the beginning, with experimentation and feedback are rewarded with nuggets of improvements and possible reform. A major campaign from Mac admins in 2022 helped ensure that new login items profile for MDM was ready ahead of the release of macOS Ventura at the fall. This new behavior in the operating system was met with a cascade of admins explaining a strong need to customize the experience of our colleagues in business and provide for them a curated experience. Indeed, many such changes have been the result of feedback from the community writ large. If we look at the release cycle itself, we get to talk a little bit about the points that exist on this release cycle. We get to say that coming in June, we get the latest version of the operating system in a beta form. Over the next 3 months to 4 months to 5 months, depending on the development cycle, we get our chance to make our mark on and understand the direction that Apple's headed in. We get our initial release at the end of that period, and then our first patch in December. In January, we get the second major patch, followed by the spring TOC release. If we think of Apple as having a tick-tock pattern, we get the initial release in the fall, in the spring, and and then we get the TOC release in the fall. The TOC release for Ventura was just released Monday. We get a 4th minor release in April and May, a 5th minor release in May and June, and then onward we get security releases for 2 years. And so let's talk a little bit about security releases here. This note from the Apple Platform Security Guide, or Platform Deployment Guide, is very, very clear. Note, because of dependency on architecture and system changes to any current version of macOS, for example, macOS 13, not all known security issues are addressed in previous versions, for example, macOS 12. This means that the operating system, while it has a 3-year patching period, effectively has a 1-year lifespan for security releases. After the final release, of which I'm expecting 10.13.5 will be our terminal release this summer, we get to migrate into the new macOS 14, assuming it's called that, as we get into the springtime. I also want to talk a little bit about feedback as an art form, and I'm going to try and talk faster because I'm running out of time, or I'm out of time already. If we think about the rules for writing great feedback and the amount of time in which you have to do this, you have 6 jobs. Start from what you expected. Describe what happened instead. This is my favorite single bit of advice. You expected something to happen when you did something as an admin or a developer. It didn't happen. What happened instead? And then you need to describe the time and effort savings that you desire out of any fix that Apple provides. In addition, you need to provide examples in code. You need to center yourself with context. You need to provide Apple the reason you are asking for what you are asking for, because they may not understand your environment. It's your job as an admin or a developer to make it very clear to Apple what you wanted to have happen in that moment and why. Because the product manager needs to know the why, and the engineers need to know the how. Last but not least, Ted Lasso gave me this one yesterday. Clarity is the true soul of wit. And so being clear as well as being brief work in your favor. So once you've filled out that feedback request, it's also important for you to lobby your friends. Lobby your enemies, lobby your neighbors, lobby your pets. We encourage as much feedback as you can possibly derive from the situation. Creating signal out of the general size of radar's noise is a hard challenge. So I also wanted to talk very, very briefly about cycles of change and learning, because once you know you're in a cycle, you can spot the patterns. Spotting when patterns change and choosing to remain zen amidst the chaos represents a major a major improvement in your quality of life and your work stream. We've talked about the cycle of Apple events, and though it's not written on tablets at the center of Apple Park, or at least I don't think it is, maybe that's what that is in the center down there. These patterns don't just represent the cycle of events, they also represent a cycle of change and a cycle of learning. We get new features, so we have to learn how they work. We get new APIs or new versions of Swift, so we must learn how they work. New features drop, new hardware sometimes arrives, and so we get practice and patience and engagement. Being ready for the tiny beta cycles of a .2.x release or the big bang beta cycles in the June and July timeframe means having a cycle of change and learning in mind. And so if we think about these cycles and what you must do to be prepared, you've got to document your cycle. You have to know where you are within it. For example, we're there in that spring talk release. Sorry, fall talk release, Northern Hemisphere guide, apologies. But, if we think about, you have to know where you are. And I don't know why my slide is repeating. You also have to document your exit criteria and your tasks as part of that process. And then you must prioritize ruthlessly what is actually on your task list. Do you need to adopt the latest version of ARKit? If you're a systems administrator, probably not. If you're James Thompson, who makes his, PCalc app and that's part of his deal, yeah, you do. But chances are you get to make that decision as the developer. You get to make that decision as the admin. And so you also need to communicate your expectations and your goals to your stakeholders. And then you need to rinse and repeat, because the cycle never ends. I also want to take a quick moment to talk about the impossibility of soothsaying, because we are constantly bombarded by the latest rumors about what's coming out, the latest, AR goggles nonsense that happens to be flying through the system. You have no control over that. You have no idea how useful the information is that's being communicated to you. You have no idea why you're getting the information that you're getting. Discard it all. Or make smart decisions based on what you know to be true and what you know that you can do in the event that you have to. Making decisions based on preventing one-way doors as a part of that process, going through a door to service a field that you need, isn't there. So as part of this, I do need to wrap up here, and we're just a little bit out of time. What I'm going to ask for you all to think about are these priorities. You need to determine the effort involved in every one of those tasks and determine the prioritization of the work that you're going to do, whether that's table stakes work, whether that is differentiating work, whether that is strategic or opportunistic work. And then you have to align your priorities to that rubric. So I will leave you with this QR code. And this is by a solid product manager who's out there. And I know that here in a room of developers and IT admins, product managers, maybe not your favorite people, totally understand that, deserved reputation. This year we're shipping rafts. We are not shipping boats. We are building the smallest, most minimum viable product that we have because the market differentiation that we're in depends upon it. And so if I can leave you with one quick thing, and if I can leave you, with a really important part of this, we got to chase after the ice cream truck again. We've been chasing after the cabbage truck for what feels like 5 years. And I can tell you, as much as I love halushki or a nice roasted cabbage, it is not the same as chasing after an ice cream truck. And getting back to the point where we are chasing after that ice cream truck, where we are aware of the world in which we live, if we are aware of the challenges that we face, we have to get to this point where we are excited to run down the street after that and not after the cabbage truck. And so if I can leave you with one quick thing, these cycles of change are hard. You are doing hard work every day, and it is relentless out there. So what I'm going to ask you to do is schedule your next vacation today, put in your leave request tomorrow, because June is coming. And the cycle starts anew. And we get a new ice cream truck to chase after. There's going to be new stuff in there that we love. And there's going to be new stuff in there that is going to break things all manner of ways. But we can find the joy in that ice cream truck out there. And we can pick up our IDEs and we can pick up our MDMs and we can go after that ice cream truck because that's what our users expect and demand of us. I was going to read a pithy quote about Whitman, but I'm going to leave that alone for now. Find the full transcript of this talk and all of my slides online. I'll have this posted tonight. Thank you, XWorld and DevWorld. It's been a pleasure.